Okay, so Assalamualaikum warahmatullahi wabarakatuh. Good morning everyone. So sorry lambat sikit. Akhirnya panas gila, tak boleh nak telan. Sabar je lah. Tak boleh nak paksa. Sat lah, kena bagi habis dulu. Kalau tidak, sekali kalau dia tumpah lagi sekali atas keyboard saya, nanya. Lagi sekali nak kena hantar pergi kedai waktu-waktu macam ni. Ya Allah. Sesat Oh, lupa. Apa cerita? Okay, clear, screen okay. Ada masalah apa-apa tak? Dengar okay ke? Ada bunyi ke? Kamera tak clear ke? Screen tak okay ke? Bagi tahu lah. Okay. Sabarlah. Semua okay. Alhamdulillah. Breakfast dah semua orang. Have you had your breakfast? Okay, so now let us start. So this is the third lecture out of 4. Okay, so we are going to finish chapter 5 by this week. And then next week we are going to start with chapter 6, polynomial. Okay, so function and graph. Right, so we have done functions where we already learned that in functions there are two relations. You can have either one-to-one or many-to-one. Okay, so this is functions, and then you can have composite function. So we already learned there are 3 types of composite function, either straightforward, or you must find the inner function or the outer function. So those are done as well. So today we are going to proceed with the inverse function. And if I have the time, I think we will do the exponential as well. So I'll do how to sketch the exponential graph, and then we will proceed with the logarithm next class. If I have the time, I'll proceed to exponential. Let us see how many minutes it will take to finish all those 4 example. Ada yang belum makan lagi? Tak apalah, kalau belum makan tu sambil-sambil makan. Boleh ke? Tak kisahlah, tengoklah macam mana. Okay, so now inverse functions 5.3. Okay, so the learning outcome for today, you should be able to show whether a function has an inverse and find the inverse of the function. So you have to show whether it has an inverse or not, and then you must find the inverse. Compute the inverse of a function. We actually have 2 methods, but I think I'll teach the second one, which is by using the property, because I'm sure you are quite good with the first method. So I'll be focusing more on the second method. Okay, identify the domain and range of the inverse function. So if we know what is the domain and range for f, what is the domain and range for the inverse function, which is f inverse, and then sketch the graph for both of them, f and f inverse, on the same axis. So when we are talking about sketching them on the same axis, it simply means that we need to have another line which is y equal to x. So we must draw f first, and then we draw y equal to x, and then we reflect our graph, and that is our f inverse. Okay, so biasanya kalau dia minta sketch dua-dua tu kena ada satu garis ni lah, sebab kita nak tengok dia ada reflection. Okay, so now next. Inverse function, the inverse of a function exists if and only if. If and only if, in Malay we call it jika dan hanya jika. That means must be. It must be one-to-one function. Okay, so the inverse of a function f exists if and only if f is one-to-one function. So we need to focus on one-to-one. So if you refer to lecture 1, where we are talking about one-to-one function, how do we check whether do we have one-to-one or not? Okay, so we need to do a graphical method or algebraic method. If we test by using horizontal line test, they should cut at only one point. Therefore, we know that the function is one-to-one function. If we are using algebraic method, we have to do fx1 equal to fx2, then it must implies that x1 equal to x2. So we cannot get any other value other than x1 equal to x2. So if fx1 equal to fx2 implies that x1 is equal to x2, therefore f is one-to-one function. Okay, so again, I repeat, in order to check whether do we have one-to-one function or not, you have two methods, graphical method or algebraic method. For graphical method, you can do horizontal line test. So horizontal line is those Y line, and make sure the line only cuts at one point. And then if you are using algebraic method, you are going to do fx1 equal to fx2, and you need to check whether do you only have x1 equal to x2 at the end, or do you have another one. So if you have two different value, then those are not one-to-one function. Okay, so why do we need to put more emphasis on one-to-one function? Because this is 5.3 inverse function. So basically, inverse only exists if they are one-to-one function. So that's the reason why we have to really determine they are one-to-one function first. Because basically, if they are not one-to-one, you are not going to get any inverse at all. Okay, so next. Right, so method to find the inverse function. So I think this one is normally what you use during your high school level. So algebraic method where you let y equal to fx, and then you simply change the subject. Instead of y as the subject, you change it as x as the subject. So from y to x, and x will be equal to the inverse of y. Okay, so this is F inverse. All right, and then another one is by using the property F inverse of X is equal to X, or F inverse of F is equal to X. So basically, if you have a function and then you are doing some composite with its inverse, then you are supposedly to get X back. Or if you have an inverse function and then you do the composite with the F, then you should go back to the X. Dia lebih kurang sama macam masa matrix lah kot. A darabkan dengan A inverse, kita boleh dapat I balik. So kalau untuk ini kiranya dia darabkan dengan inverse, kita boleh dapat nilai X yang kita start pada awal tu. So it's like this is the X, this is the domain and range, right? So this one to this one is Fx. If you are using F inverse, you must go back to X. So inilah sebab kenapa kita dapat X. Okay, now for me, I'll be focusing more on using the property. So algebraic method, I leave that to you. I'll teach how to use the property. Algebraic method ni simple sebab dah belajar masa sekolah dulu kan. So kita guna using the property lah, it will be easier. Okay, next. Right, so now show that the following function are one-to-one and then find the inverse function. Okay, so example one, we have two example actually inside here. We have example A and then we have B as well. So for A, I'll do the algebraic method. So for B, we are going to do the graphical method. And then if we have the time, I'll do another algebraic for B as well. Okay, so now show that the function are one-to-one. So this is our function fx equal to 3x plus 2. So now, right now, I'm using the algebraic method. Okay, so I have to start with fx1 equal to fx2. What does it mean? Is that on the left-hand side, I'll copy down this function, except that now I have to change the x to become x1. On the right hand side, right now we are changing x to become x2. So x become x1 or x become x2. Okay, so what do we have is 3x1 plus 2 equal to 3x2 plus 2. Okay, and then of course you should minus 2 on both sides. So you are going to get 3x1 equal to 3x2, and then you divide everything by 3, you are supposed to get x1 equal to x2. So deduct with 2 on both sides, and then you simply divide them by 3, you are going to get x1 equal to x2. Okay, so basically, since fx1 equal to fx2 does imply that x1 is equal to x2, then what we can say that fx is definitely one-to-one function. So definitely one-to-one function because fx1 equal to fx2, it will give us x1 equal to x2. So this is definitely one-to-one function. Okay, so now in order to find out the inverse, I'm going to use the property for them. So what is the property? So normally I'll use F composite with F inverse equal to X. And then I'm trying to make F inverse as the subject because that is basically what we want to find. Okay, so what is Fx? Okay, so Fx is 3x plus 2. So F composite with F inverse, it simply means that from X here, I have to change the X to become F inverse. Okay, so copy down again, but this time change the X to become F inverse. So they will become 3F inverse plus with 2 equal to X. And then you are supposed to make this F inverse as the subject. Okay, so deduct with 2, divide them by 3. So F inverse of X is equal to X minus 2 over 3. So that is basically our F inverse. Quite simple, right? It's not really hard. Quite simple. I think so. Okay, so this is by using the second method, which is using the property. Okay, next. Show that the following function are one-to-one, find the inverse function. Okay, so this time we have px equal to negative x squared plus 5. And then we have a restriction. So this is the restriction for the domain. X will be greater than or equal to 0. Okay, so now, how does negative x squared plus 5 looks like? So this is basically a quadratic graph. So you might want to find the vertex first. Okay, so what is the vertex? So this is already incorporating the square form. So I'll just compare them with ax minus h square and then plus with k. So when I compare them, we should be able to see that h is actually 0. And then the value for the k is simply 5. And then of course, we have to determine whether they are a maximum point or a minimum point. So maximum or minimum. So that totally depends on the value of A. So if you look at them, the value of A over here, the A is negative. So A is negative, that means it should be a sad graph. So cannot lah. Bukan yang happy graph tu lah, sad graph. So this is definitely a maximum graph. Okay, so the maximum graph, this is 0, 5. Okay, but x need to be greater than or equal to 0. So make sure you have your eraser. And then starting from here, because this is when x equal to 0, right? So when if you have your eraser ready, make sure you erase this part. Because we need to make sure that the x is greater than or equal to 0. So your graph, instead of looking like this, you must erase the left hand side. So something like this. Okay, so let us draw them. Okay, so this is basically my graph. Okay, so this is negative x square plus with 5. And this is for x greater than or equal to 0. Okay, so just in case you were wondering what happened if we have this equal sign over here. So actually they does include 0. So kalau ikutkan lukisan kita sepatutnya dia kena gelap lah kat sini. Tapi sebenarnya kalau kita buat line tu maksudnya dia dah include dah. So those are fine. But if let's say, kenapa dia tak mau ni tak mau buat bulat. Lepas tu, okay, so they are supposed to looks like this. If let's say you don't have the equal sign, make sure you use an empty circle over here. Be extra careful, okay? Okay, so now I'm going to check first the one-to-one function. So I'm using the graphical method. So graphical method, that means I need to do a horizontal line test. So I'm drawing a horizontal line over here, and then I already test that they only cut at one point. So throughout from 0 up until infinity, they basically only cut at one point. Therefore, I know for sure this is definitely one-to-one function. Okay, so the horizontal line cuts the graph at only one point. Thus, Px is one-to-one function. Okay, so we know for sure they are one-to-one because the horizontal line cuts the graph at only one point. Okay, so that is the first one. Kenapa macam tak ramai je? Ramai tak bangun tidur lagi ni. Okay, next. I think we have the time, so let us try to do the algebraic method. Okay, so how do we do the algebraic method? So again, you must start from fx1 equal to fx2, but this one they give us p, right? So we can write down px1 equal to px2. Okay, so px1 equal to px2, and then replace the x with x1 as well as x2. So you will have negative x1 square plus 5 equal to negative x2 square, and then plus 5. Okay, so what do we do next? We deduct with 5 on both sides. We subtract 5, and then we times them with negative 1. Okay, so we are supposed to get something like negative x1 square equal to negative x2 square, and then we times them with negative 1. So we have x1 square equal to x2 square. Okay, so since we have a square, in order to get rid of the square, we have to apply square root. But do remember, when you are applying square root, so since this is an even power, you must have the plus and minus sign. Okay, however, we do have a restriction for our domain. The domain said that x will be greater than or equal to 0. So since x must be greater than or equal to 0, we must reject x1 equal to negative x2. So we only accept one of them because we have a restriction on the domain. So this is the reason why you have to understand, do we have a restriction on the domain or not? Okay, so now, but since it's given that x will be greater than or equal to 0, thus x1 is equal to x2. So that means that px is definitely one-to-one function. Definitely one-to-one function. Okay, so those are the graphical method as well as the algebraic method. We haven't calculated the inverse yet. So those are simply just to test they are definitely one-to-one function, because if they are not one-to-one, there's no point for you to calculate the inverse, because the inverse does not exist if the function is not one-to-one function. So that is why we have to check first. Okay, let's go. How to calculate the inverse? Okay, so again, I'm using the property. So P composite with P inverse must be equal to X. So every time I see X over here, I will replace them with P inverse. Okay, so they will become negative P inverse of X square plus with 5. And then we need to make this P inverse as the subject. Okay, so I'll deduct them with 5 and then I times them with negative 1. So P inverse of x square is equal to 5 minus x. Okay, so what happened over here? Again, I repeat, I bring this one to the right hand side. So they will become negative of P inverse of x square equal to x minus 5, and then I simply times them with negative 1, so they will become P inverse of x square equal to 5 minus x. Okay, and then we have to get rid of the square, therefore you have to apply square root for them. So P inverse of x is simply equal to the square root of 5 minus x. Okay, so we only choose the positive part because we have a restriction for the domain where the x must be greater than or equal to 0. So actually over here you do have plus and minus square root of 5 minus x. However, we only choose the positive of square root 5 minus x instead of negative 5 minus x. This is because the domain for P is greater than or equal to 0. So that means you cannot have negative over here. So that's the reason why we only choose the positive one. So P inverse is equal to the square root of 5 minus x. So those are the inverse function of P. Okay, let's go next. Right, so now domain and range of the inverse function. Okay, so now the domain for f is actually equal to the range of f inverse. And then the range of f, this is actually equal to the domain of f inverse. Okay, so the reason why we are having this kind of relation over here is because it will be easier for us to check the domain instead of the range. The range, sometimes you have to refer to the graph. You must sketch the graph a little bit before we can see what is our domain. So it will be easier if we know the domain for f and the domain for f inverse, then we can find out what is the range for f and range of f inverse. Okay, so domain for f is equal to the range of f inverse. Then the range for f is equal to the domain of f inverse. Okay, so normally we are going to use this when we want to find out the domain and range for either one of the function. Tengoklah kadang-kadang dia ada certain function tu lagi senang bila kita cari domain sebab domain yang ada masalah dekat 3 keadaan saja kan. Log, reciprocal dengan log, reciprocal dengan square root. Ada 3 je. Selain daripada tu dia tak ada banyak masalah sangat. So that's the reason why we are using this kind of thing. Okay, next. Right, so the graph for f inverse is obtained by reflecting the graph for y equal to fx about the line y equal to x. Okay, so normally if you have to sketch both of them together, what do we do is that after you have your x-axis, y-axis, and then after you sketch the graph fx, you need to have the line y equal to x and then you must reflect them. So you must reflect your graph using this line y equal to x, and those are actually our f inverse. Let's say if you sketch them and suddenly you see that they are not really reflecting, then most likely you sketch them wrong sebab sepatutnya graph tu dia memang akan reflect lah. So this one will be very useful, especially if your fx is a cubic function. So if your fx is a cubic function, it will be quite easy if you can sketch your fx first before you obtain your f inverse, because we didn't know how to actually sketch the cube root of something, right? So we never learn how to sketch a cube root of something. So that's the reason why if we use this one, it will be easier for us to actually sketch the graph for the cubic as well as the inverse. Kalau untuk kuadratik senang sebab inverse dia adalah square root. Exponential pun okey lagi, inverse dia adalah log. I think the hardest part will be for cubic function sebab kita tak belajar cube root. Saya macam ada orang message je. Oh, okay. Right, done with this one. Miss, dua-dua method ni kena tunjuk atas salah satu je. Either one. You are talking about this one, right? Graphical or algebraic method kan, Hakim? So, kalau nak tunjuk sama ada dia one-to-one function, you can choose either one. Either graphical method or algebraic method. So, normally for me, I prefer graphical method when it comes to a quadratic function, because for quadratic sometimes it will be quite hard for me to see whether do they cross the maximum or minimum or not. Sebab kalau kata dia ambil nombor sebelum daripada maximum atau minimum tu, dia bukan one-to-one function. So normally for me, for a quadratic, I'll choose graphical method because it will be easier for me to check they are really one-to-one function. If let's say we have some quadratic, some linear function, some reciprocal, some square root, then those are quite easy if we use algebraic method. So my opinion, if I have a quadratic, I'll use the graphical method. Otherwise, normally I'll use the algebraic method. Kalau kita nampak graf tu macam kacang je nak lukis, graphical lah. Kalau kacang. Okay. Right, so now, example 2, find the inverse for px equal to 1 over x, 1 minus x plus 2. X cannot be equal to 1. Okay, so now we have a restriction over here. X cannot be equal to 1. But that is true because if we have 1, we are going to get 0 in our denominator and everything will be undefined. So this is okay. And state the domain of the inverse function. Okay, so now let us find out what is the inverse for this. So I'm going to use the property where we have f composite with f inverse equal to x. So I always use the second one. If you want to, you can use the first method, but I always use the second one. So f composite with f inverse must be equal to x. So every time I see the x in f, I will replace them with f inverse. Okay, so 1 over 1 minus f inverse of x plus 2. So this is basically equal to x. So we are going to bring positive 2 to the right hand side. So they will become negative 2. And then we are going to take the reciprocal for them. Okay, so you can do that or you can times them, up to you. Okay, so this one they are doing some times, but never mind. I want to use 1 over 1 minus f inverse of x equal to x minus 2. Okay, and then like I told you before, we can easily take the reciprocal for them. So 1 minus f inverse of x is simply 1 over x minus 2. Okay, this is over 1. And then you can have your f inverse as your subject. So you can do that as well. Or you can use this method where you simply times everything with your denominator. That totally works just fine. Okay, so what happened here is that they are going to collect all the f inverse, go to the left. Everything else without the f inverse will go to the right hand side. So kalau kita buat method yang macam ni where we multiply with our denominator, do make sure to collect all the f inverse, go to the left first. Okay, so collect all the f inverse, go to the left. So this one stay on the left. This one will go to the left. And this one will go to the right hand side. Okay, so f inverse of x, x minus 2 is equal to x minus 3. And then we will have f inverse of x is equal to x minus 3 over x minus 2, where x cannot be equal to 2. So we put a restriction over here because this is a fraction, right? So we cannot let our denominator equal to 2. Otherwise, everything else will become undefined. Okay, so now what is the domain for the inverse function? So we already said over here that x cannot be equal to 2. Then I think you can easily see, like, so the domain will be negative infinity up until 2 to up until infinity. So that is the domain over here. If you want to, if let's say the question asks for the range as well, then you simply refer to the domain of your f. So domain for f, x cannot be equal to 1, therefore negative infinity up until 1, 1 up until infinity. Okay, so those are the inverse, and then the domain and range. Okay, so done with example 2. Let's proceed with example 3 and example 4. Okay, so now function f and g are defined as fx equal to 2x minus 5 over x plus 3. Gx is 3x plus 5 over 2 minus x. Okay, so firstly, they want you to find what is fgx and deduce f inverse. So that means there must be something with fgx because they want us to deduce what is f inverse. So if we want to deduce, they must come from fgx. So fgx will give us something. Okay, so now I'll give you a few minutes for you to calculate your FGX, and then together we will deduce what is F inverse, and then we are going to determine the domain and range for F inverse. Okay, so calculate your FGX first. So I'll give you around 2 minutes, I think, until 8:36. In the meantime, I'm going to check your attendance. Oh. Oh, by the way, I already opened the link for the attendance, so you can click on the same link that I give you. But make sure to choose today date. Make sure hari ni punya tarikh. Siapa yang dah key in ni? Sekejap kita tengok siapa yang laju sikit. Irfan dah key in. Lagi siapa lagi? Daniel Nur Hakim key in dah. Irfan Zulkarnain. Lagi siapa lagi ni? Siti Nur Afrina dah key in. Nur Asfar Syazwani dah key in. Nur Faika pun dah key in. Suraya dah. Ulia Fiksiah dah. Aziz Saika dah. Ilhan dah. Nadia Fariha dah. Pergi. Nurul Ain dah. Siti Nur Alia dah. Ni macam nampak ada yang masuk ni. Suraya. Siapa ni? Ainul Auni. Azam Shah pun dah. Okay. Key in je lah. Oh lupa. Siapa yang tak boleh masuk. Lupa pak. Oh dah. 837 dah. Galik. Okay, so how do we find FGX? So FGX, this is composite function, and those are case A. Case A where we simply substitute them inside, right? So FGX, that means we are going to substitute G inside the F. So every time we see the X in F, we are going to replace them with G. So they might look a little bit intimidating at first, but never mind. Okay, so now what happened? They will become 2 multiplied with 3x plus 5 over 2 minus x minus 5 over 3x plus 5 over 2 minus x plus 3. Okay, so normally what happen next is, if let's say we have a fraction and then inside the fraction has another fraction, right? So normally I will advise you to change everything into a single fraction, because when we change everything into a single fraction, our calculation will be much more easier. It will be easier for us to handle the calculation when everything is in a single fraction. Okay, so what I normally do is that I'll times them with my denominator, just to make sure that in my numerator I have a single fraction with the same denominator, and then basically in my denominator I have a single fraction with the same denominator as well. And then since I have fraction over fraction, I'm going to times with the reciprocal, and that will change everything to a single fraction. Okay, so now kita samakan pembawah semua, samakan pembawah, and then darab dengan dia punya pusingan tu. So what we are going to get is 2 times 3x plus 5 minus 5 times with 2 minus x, and then 3x plus 5 plus 3 multiplied with 2 minus x. And then you just need to simplify them. Okay, so 2 times 3, so this is 6x plus with 10, and then negative 5 times 2, so negative 10, negative 5 times with negative x, so this is positive 5x. And then in our denominator over here, we got 3x plus 5, and then we got 3 times 2, which is 6, and then 3 times negative x, so this is negative 3x. So when you cancel out, you will get 6x, 5x, 11x over 11, which will give us x. So fgx is simply equal to x. Okay, so this is basically the reason why I normally use the property, because if you use the first one, you cannot really see what is your f inverse. But if you use the property, you know for sure that only when f composite with f inverse can get x. So I know for sure what is my f inverse. So sebab tu kalau untuk saya biasakan diri saya guna property, because I need to remember about this thing. Okay, so f composite with f inverse must be equal to x. So I know for sure that my f inverse is simply equal to g. G must be my f inverse. Okay, so now what is your f inverse? F inverse is g. So that means our f inverse is 3x plus 5 over 2 minus x. So we are done with A. So now B, determine the domain and range for f inverse. Okay, so look at your f inverse over here. We have 2 minus x in our denominator. So that means x cannot be equal to 2. So that means for the domain of f inverse, I need to avoid 2. So they will become negative infinity up until 2 union with 2 up until infinity. But for the range, it will be easier if we refer to the domain for f. So if you check your f, you should be able to see that in your denominator, you have x plus 3. So that means x cannot be equal to negative 3. So that means my range of f inverse will be negative infinity up until negative 3, union with negative 3 up until infinity. So that is basically how we get our the domain for f inverse and range for f inverse. Okay, so domain, I refer to them straight away. The range for f inverse, I'm referring to the domain of f. So I'll check the domain for f and then I'll use them for the range of f inverse. Okay, so done with that. Next, let us go to example 4. Because we haven't done some sketching part yet, so we need to sketch. Okay, so given that fx is x minus 1 square plus 2, where x is greater than or equal to 1, so do check over here, we have a restriction for the domain. That is most likely because if we don't do any restriction for the domain, the quadratic graph will not be one-to-one function, hence we will not have any inverse. So that is probably why they are doing some restriction over here. Okay, so find the F inverse and state its domain and range. Okay, hence sketch the graph for fx and F inverse on the same axis. Alright, so now we need to find the F inverse. So I'm going to use F composite with F inverse equal to x. Okay, so every time I see the x inside here, I will replace them with F inverse. So F inverse of x minus 1 square plus 2 is equal to x. And then of course, I'm going to bring this one to the right hand side. So they will become x minus 2. And then I'll apply the square root for both of them. And then we are going to do plus 1. Okay, so now bring positive 2 to the right. So we have F inverse of x minus 1 square equal to x minus 2. And then of course you have to apply square root on both sides. So F inverse of x minus 1 is equal to the square root of x minus 1. Again, I should remind you that when we are applying square root, we actually have two things, the plus and the minus. However, referring to my domain over there, where I have x greater than or equal to 1, so I should choose the positive value. So that's the reason why I'm ignoring the negative value. Okay, so now F inverse of x minus 1 is the square root of x minus 2. So F inverse of x will become 1 plus the square root of x minus 2. So this is our F inverse. Okay, so now how to find the domain and range for this F inverse? Okay, domain. This is our F inverse, right? Domain, this is a square root, so you have to refer to the number inside of the square root. So x minus 2 will simply be greater than or equal to 0 because this is a square root, so we can let them be 0. Oops, kenapa tak keluar ni? Jom. Hilang. Okay, so x minus 2 will be greater than or equal to 0, which means that x will be greater than or equal to 2. So that one will be our domain. For the range of F inverse, I simply want to look at the domain for the F. So the domain for the F is x greater than or equal to 1. So I'll use them for the range of F inverse. So they will become something like this. So the domain for F inverse, so this is already calculated over here, x greater than or equal to 2. So that's the reason why you have 2 up until infinity. Be sure to use the square bracket because we are actually including the 2. And then the domain will be 1 up until infinity because over here we do have the equal sign. So 1 until infinity. Okay, so that is actually the domain and the range. And then of course you have to sketch both of them on the same axis. Okay, so make sure to draw this one first. This is a simple quadratic graph. So saya bagi terus je lah graph dia. Okay, right, so now draw your fx first. So this is a quadratic graph where the minimum is at 1, 2. So the minimum is at 1, 2. So x is equal to 1, y is equal to 2. So this is basically how our graph for fx looks like. And then you have to sketch or you have to draw the line for y equal to x. So nanti ambil ruler, draw y equal to x, and then you simply reflect them. So that will become your F inverse. Okay, so you can actually check for this square root, right? So we must add 2 and 1. Okay, so kalau nak senang cerita, biasanya dia akan opposite lah. Kalau kita tahu nombor kat sini, nombor dia berapa, and then tukar kedudukan untuk X dengan Y, so kita tahulah nombor yang dekat sini nombor berapa. So dia sepatutnya kena reflect. Okay, so yang ni 1, 2, yang ni akan jadi 2, 1. Okay, so do make sure when they ask you to sketch both fx together with f inverse, you must have the line y equal to x. So be extra careful then. Okay, so I think that's it for lecture 3. So we still have another 10 minutes to go. So I'll do lecture 4, exponential function. Okay, so now sketching exponential functions. Okay, so sketching exponential function, normally for me, I'll say you have 3 steps for them, where we can actually call them as ICA. IQA, ICA. So siapa nama ICA tu, kita guna ICA punya method lah. I stand for the intercept, Q stand for quadrant, and then A stand for the asymptote. Because how the exponential looks like is that if you have this X, this Y, so we must draw our asymptote. So this is our asymptote. And then if let's say this is your intercept, right? So this is the I. This is the asymptote. So the quadrant will be either on the left hand side or right hand side. So what they tell you is that you must start from the asymptote, cross the intercept, and then you must go to your quadrant. Okay, so it will look like this or something like this. So dia nanti mesti kena rapat dengan asymptote tu lah. So cara lukis dia lagi sekali, X, Y. If let's say we already have the asymptote, so ini adalah asymptote. Katakanlah intercept dia dekat sini. Okay, and then quadrant dia, katakanlah kita dapat quadrant dia yang bawah ni. So kita akan lukis dia rapat dengan asymptote kat sini. Cross dengan intercept, turun bawah. Kalau kata quadrant dia dekat sebelah sini, kita akan lukis dia rapat dengan asymptote, cross intercept, dan terus pergi ke quadrant. So those are how we are going to sketch them. I'll teach you later on how to find the I, the Q, and the A. So basically those are the main idea. So you need to know your asymptote, you need to know what is the intercept, and then you have to know where is the quadrant. Because kita nak pergi sampai positive infinity tu, sebab tu kita kena tahu quadrant kita kat mana. Okay, so now for exponential function, we actually have two kind of graph actually. So I'll be focusing more on fx equal to ax, where a is greater than 1, because normally we have to sketch something like e to the power of x, or 3 to the power of x, or 2 to the power of x, where the number is simply greater than 1. But I do feel that perhaps in our tutorial class, I'll teach you how to sketch this graph if we have a in between 0 and 1. Actually, they are similar except that the quadrant over here is a little bit different untuk a in between 0 and 1. But let us focus more on this one first. So kita akan fokus yang sebelah kiri dulu, and then nanti waktu tutorial baru saya akan tunjuk lah apa beza dia dari segi quadrant tu. Okay, so now I is the y-intercept, Q is the quadrant, and then A is actually the horizontal asymptote. Okay, so how do you find the y-intercept? The y-intercept is always when x is equal to 0. So we're going to substitute when x equal to 0, what is the value for the y? So that one will become the y-intercept. And the quadrant, for the quadrant, okay, so the first one over here, the plus or the minus sign actually refer to the coefficient of x. So you should check your exponential function, what is the coefficient of x? So if they are positive, then simply write down positive. If they are negative, then you simply need to write down negative. So those are the quadrant. Okay, the second one actually the sign in front of the exponent, in front here. Okay, so in front of A, what sign do you see? Is it a plus or is it a minus? So if it is a plus, then use a plus. If they are a minus, then use a minus. So it can be both either plus or minus. Okay, so what do they mean? Okay, so if this is the x-axis, this is the y-axis. Okay, so it's like a positive value of x and y. So if you have positive, then they are definitely in the first quadrant. So this is negative, positive. This is negative, negative. And then this is x positive, y negative. So this one will refer to where are we going to the infinity. So dekat mana kita nak go to infinity tu, dekat quadrant mana. And then asymptote is normally when you have a to the power of x, you need to see whether are you adding with something or minus with something. So this is actually our asymptote, the horizontal asymptote. So we are going to refer to this number over here. If you didn't see anything, if you simply have a to the power of x, then it simply means that the number at the back over here is 0. Okay, so now let us proceed to the example. Okay, so we have quite a lot, but I think I'll do around 4 of them, and then I'll leave that to you guys to do E, F, G, H on your own. Okay, so now fx equal to e to the power of x. So now the y-intercept, what happened when we substitute x with 0? Okay, so substitute x with 0, you are going to get e to the power of 0, and e to the power of 0 is actually equal to 1. So those are our y-intercept. And then the quadrant. The quadrant, okay. Now, do check what is the coefficient in front of the x. The coefficient of x. So this is positive. So your quadrant will be positive for the first one. For the second one, look at the coefficient of E or the number in front of the E. Okay, so nombor E. E ni ada darab dengan apa-apa nombor tak? Kalau tak nampak apa-apa nombor ni maksudnya 1 lah kat depan ni. Okay, so 1 is actually a positive number. So the quadrant for them will be positive, positive. Horizontal asymptote, do you see them adding with any number? So I don't see them adding with any number. So that means the number at the back over here is simply 0. So the horizontal asymptote is when y equal to 0. Okay, so now make sure you are ready with your ruler as well as your pencil. Okay, so make sure to have the x and the y axis. Okay, so x and the y axis, and then make sure to have your intercept as well. So intercept dia adalah 1. So this is 1. And then the quadrant positive, positive. So that means my graph will go over here. And then horizontal asymptote is at y equal to 0. So draw a dotted line over here. Just to remind ourselves, this is actually asymptote. Okay, so make sure to draw your graph. Always start from the asymptote going to the intercept. Okay, so this is our asymptote. So lukis yang rapat lah. Rapat tau, jangan cross. Kalau cross tu salah. So dia kena rapat je. So rapat, pergi dekat intercept, and then pergi dekat quadrant. So jauh. Macam tu. Okay, one more time. Okay, so y equal to 1. So when x equal to 0, y is equal to 1. So this is when y equal to 1. So that is your intercept. And then quadrant, positive, positive. So positive value of x, positive value of y. So go further, pergi hujung-hujung sikit. Sebab kita nak go to infinity tau. So go hujung sikit. Okay, and then horizontal asymptote is at y equal to 0. So make sure you draw your asymptote. Y equal to 0. So when you start drawing, so normally I will advise you to start from the asymptote. So start from the asymptote, close to the asymptote, and then make sure you cross your intercept. Okay, so close, and then kita kena cross kita punya intercept, and then go to the quadrant. Ni nampak macam tak cantik sikit lah, tapi dia sepatutnya macam ni. Dia bila lukis panjang ni memang nampak macam pelik sikit. Jangan nampak 2 line macam saya ni lah. Nanti kan salah. Okay lah, saya tunjuk yang cantik. Okay. So that is basically how the graph looks like. Done. Okay, so that is the first one. Let us proceed with the second one. Oh, the domain and range, I forgot, sorry. Okay, so the domain always start from negative infinity to infinity because for exponential, they are not within the 3 things, right? that have some problem with the domain. So the domain for f can be negative infinity to infinity. But for the range, you have to start from the horizontal asymptote. So horizontal asymptote is 0 over here. So ini adalah horizontal asymptote dia. And the graph is always above the horizontal asymptote. So your range will be 0 up until infinity. If let's say your graph is below your x-axis, then it's supposed to be negative infinity up until your horizontal asymptote. So kita kena refer to the graph lah, bawah x-axis ataupun atas x-axis. Tapi biasanya mesti kena ada asymptote lah kat situ. Sama ada asymptote tu hujung sebelah kanan ataupun dia start pada sebelah kiri. Okay, next. E to the power of negative x. Okay, so now again, we are going to do the same thing, substitute what happened when x equal to 0. So we got y equal to e to the power of negative 0, which means that y is equal to 1. The second one for the quadrant, again, do check the coefficient of x over here. So the coefficient of x is negative. And then the number in front of the e, so the number over here is actually 1. So that is positive. So negative, positive. Horizontal asymptote. Okay, so do we see any number at the back over here? No, so this is plus 0. So the asymptote is y equal to 0. Okay, so make sure you have your x-axis, y-axis, and then draw your horizontal asymptote. Horizontal asymptote. Okay, intercept y equal to 1, so up here, then y equal to 1. Negative, positive, so negative value of x, positive value of y, so up here then. So dia mesti kena bucu tau. Bayangkan dia ada kotak lah, bucu, 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 bucu. Okay, so now, like I told you before, I always start from the asymptote. Okay, so this is where I need to go, so I must start from the right hand side then. Okay, so start from the right hand side. Make sure you meet your intercept. So yang ni kena turun sikit lah bagi dia jumpa. And then we must go to the quadrant. So, okay, so something like this. So that is your graph. So always make sure to start from the asymptote. Make sure to touch the intercept, to cross the intercept, and then go to the quadrant. Okay, so let's see the beautiful one. Sebab ini tak lawa. Okay. Right, dah lawa sikit lah graf tu. Okay lah. Right, next. Lagi dua Kita tunjuk lagi dua. Lepas tu kita go to tutorial lah. Ke nak satu je lagi? Okay, so this is negative infinity to infinity. For the range, this is actually above the x-axis, so you should start from the horizontal asymptote going to infinity. So the range will be 0 up until infinity. Okay, so now I think I'll do just another one lah, satu lagi dah. Lepas tu you buat sendiri lah. Okay, so D, fx is negative e to the power of x. So intercept what happened when x equal to 0. So make sure to substitute x equal to 0. So we got y equal to negative e to the power of 0. E to the power of 0 is 1, so they will become negative 1. And then the quadrant, so do check first. Okay, so the coefficient of x is positive. What about the number in front of the e, or dia macam nak kata coefficient of E pun boleh lah juga kot. Sin of E ke apa ke kan. But do check this number over here. So this is actually negative E. So they will become negative. So positive, negative. Horizontal asymptote. So I don't see any number at the back over here. So this is simply plus 0. So the horizontal asymptote is y equal to 0. Okay, so make sure to do the x and the y-axis, and then asymptote is over here. Intercept is negative 1, so below here this is negative 1. The quadrant, x is positive, y is negative, so below here then. Okay, so make sure you start from the asymptote on the opposite side of your quadrant. So start from here and then you must meet the intercept and then keep on going until you reach the quadrant. So something like this I think. Macam tu. Kurang lah. Okay, so now graph yang cantik macam biasa. Graph yang cantik. Okay. Right, so that is how they looks like. Okay, so make sure be extra careful. These two graph or these two line, the y equal to 0 as well as the graph, make sure they don't cross or don't touch. Jangan sentuh, jangan cross. Dan satu lagi, jangan patah balik. Macam saya kata, dia kena rapat dengan asymptote kan. So dia tak boleh macam ni tak boleh. Dia kena rapat. Maksudnya dia kena rata baru dia naik. So dia tak boleh macam macam tu. Tak boleh. Dia mesti kena macam smooth je. Okay. Dah smooth je Right, so that's it. So I'll see you guys later untuk tutor. So saya bagi rehat 5 minit. Nanti saya bagi link untuk Google Meet macam biasa. Lepas tu nanti kita masuk tutor lah. Okay, so I'll see you guys sekejap lagi. I'll see you guys sekejap lagi. So untuk yang lain, kalau tengok waktu lain, I'll see you guys this Wednesday. Thank you. Bye-bye. Have a nice day semua orang. Pergilah minum 5 minit je lagi. 5 minit je saya bagi rehat. Sabar je lah. Bye-bye.